This is the solution video for problem set 9, problem 1. And in this problem set, we will be working with with this architecture here, and the functions as defined on the back side of that. And so basically I have two RTL instructions here, R10 plus R5 being stored into M of R4, and R8 being stored into R3. And the question is whether or not I can implement this RTL instruction. So here I notice I'm doing an addition and storing this into memory. And so my memory controls are here. Here's the address and here's the data out. And the question is, can I put a function of two registers onto this data outline? This is the first question we have to answer. We look down here, this is where the functions happen. This is where all the magic and all the addition happens. And this output's here. This would have to come all the way back through the clock register file, wait for a whole nother clock cycle, and then we'd have to call another set of registers to get this to the data out. That's not going to work. So immediately we can say we cannot implement this RTL instruction. So I have an option. I can either not do a memory write, or I can not do the function. I'm going to choose to not do the function. And so I'm going to implement R10 into M, R4, and R8 into R3. So R10 is my data, so it's going to be B, so 10 is 1010. R4 is my address, so that will be 0100. And then, since I'm not storing into D, because I'm storing into memory instead, I don't care what DA is. I need MB1 just here to be 0, so I select B. And I don't care what my function unit does now, so I'm just doing a memory store. And I need MD to not be anything in particular. And I need my read-write to be 1, so I don't write. So this is a read signal, not a write. And then I have R8 into R3. So 8 is my source register for C, and as my function will show me, 000 is C into E. So 8 is 1000, 3 is 0011, MB2, well, I don't care because I'm not using B, and FS2, as we saw just a second ago, is 0000, and I will be writing to register 3, so I'm going to put a 0. Next up, I have two RTL instructions, R11 into R7. Well, R11 ANDed with R1 into R7, and I have R10 into memory R1. So this needs to be B, and this needs to be my A. So I'm going to need to put these on this side because that's how I do memory out, just like we saw a second ago. And so if that's the case, I also want to do R11 and R1 ANDed together. Since the architecture here needs one of those to be B and one of those to be C, I have to change one of these. And so, since I've decided this one's B already, let's just change this to R10, and no. And so now this is our B. So this is 1010. A is 1. And we're not writing it to D again, so we don't care. And everything else about this is going to be the same. And now we have RC ANDed with RB going into E. So C and B going into E is 01000. And RC will therefore need to be 11, which is 1011. And we're going into 7, which is 0111. MB2 is going to be 0 because we need B to come out. And my read-write will need to be 0, so I actually write to R7.